Okay, so you want to solve this system, and you want to solve this system by graphing. Okay. Now, when you do this by graphing, you need to make sure that you're using a straight edge. If you're using a just by hand drawing the line by hand, it may not intersect in the correct spot that it needs to intersect in. So you need a straight edge whenever you're graphing something, whenever you're solving a system by graphing. Now, we talked about the fact that this system has how many equations? Two. You can have system with two or more equations. And here we're only focusing on two equations. That's all you're going to have. These two equations are linear. So that means if you were to graph each one individually, you would have a line, right? You'd have a line. Now, last time we talked about the fact, and listen to the question. How many solutions does this first equation have? An infinite number. That's why we graph it because when we graph, we're indicating the solutions. So you can't miss the solutions. There are an infinite number of those. That's why we graph it. The second equation has how many solutions? An infinite number. But when you solve the system, you're trying to see of all the solutions the first one has and all the solutions the second one has, when we solve the system, we're looking for the one that they have in common. We're looking for the point that they have in common. And so when you solve a system, if they do have a solution, it's going to be where those two lines intersect. That's what we talked about last time. Where the two lines intersect. That's the solution. All right, so when you're doing this by graphing, you're going to graph each one individually. So let's go ahead and graph the first one. You learned two ways to graph something like number one, like the first equation you see. So I'm going to go ahead and just rewrite this over. You learned two ways of doing this in a previous course or courses. The first way is to notice that this equation is in slope-intercept form. Y equals mx plus b. So this is in slope-intercept form. Whenever you have y by itself, that's slope-intercept form. All right, so remember y equals mx plus b. So whenever it's in slope-intercept form, to graph the line, you can use the slope of that line, and you could use the intercept of that line. Because to graph the line, how many points do you need? Two. You need 2 points to graph the line. And you can easily get those 2 points from that information. Now remember though, when it's in slope-intercept form, the coefficient of x is your slope. So in this particular case, what is my slope? Negative 5/3. And remember, slope, one of the terms that you learned was rise over run. Change in y divided by the change in x. Rise divided by run. Now, we use the word intercept in that phrase, slope-intercept form. Whenever the line rises or falls, there's an x-intercept and a what? Y-intercept. What intercept am I talking about here? The y-intercept. So that intercept, when I use the phrase slope-intercept form, that intercept is your y-intercept, not the x. That's your y-intercept. So b is the y-intercept. So that's where the graph crosses which axis? The y-axis. So in this case, what is the y-intercept? Where does the graph cross the y-axis? At 1. That's where the graph crosses the y-axis. All right, so we're gonna remember to graph a line. I need how many points? 2. I know one of them already. That's the y-intercept. So where does that line intersect the y-axis? At 1. So go ahead and put a dot at 1 on the y-axis. And I need one more point, and that's where the slope comes in. What's the slope? Negative 5/3. And I tend to, it doesn't matter, you can put the numerator negative or the denominator negative. It does not matter. You'll get the same line. You'll get different points, but you get the same line. So what I'm saying is this. Someone else could have said well, I'm going to use the slope as -5 divided by 3. Someone else could have said, well, I'm going to use instead 5 divided by -3. You'll get the same line, except there'll be different points on that line, which is fine. So remember, let's go ahead and do the first one, -5/3. So it doesn't matter whether you do rise first or run first. I always tend to do the rise first. All right, so my rise is -5. Rise means you go up and down. So since my rise is negative, I'm going to go down how many units? 5. So I'm going to go 1, 2, 3, 4, 5. Now don't put a dot there, because all you did was the rise. Now I've got to do the run. What's the run? 3. Is it 3? Yeah, 3. Positive though, so which way do I go from where I'm at now? To the right. So 1, 2, 3, 4, 5. 1, 2, 3. So there's the other point. I found another solution, and I can graph the line. Now I'm going to give you a ruler. Don't do it just yet. I'll give you a ruler. But let's suppose someone else had used 5 divided by -3. Let's see what would have happened. So from the y-intercept, now the origin, always start from the y-intercept. Some students, even in college algebra, some students always tend to start at the origin. That's not where you start. You use the slope from the y-intercept, because the origin is not a solution of this line. So from the y-intercept, I'm going to go up 5 units. So notice 1, 2, 3, 4, 5. And then my run, if I use the second fraction, is -3. So which way do I go? To the left 3. Okay, let's do this again. 1, 2, 3, 4, 5. 1, 2, 3. And if I did this correctly, all these points should be collinear, meaning that they should lie on the same line. So let me go ahead and give you a ruler. All right, so let's go ahead and graph this. So I get this line. And it may be that when I draw the other line, I may have to extend this one. That's fine. We'll see what happens when I graph the other one. Okay, now let's go ahead and graph the other one using the same ideas. So I'm going to go ahead and graph y equals -1/3 x minus 3. So notice that y by itself, it's always a good idea to get y by itself, because you can easily use the slope in the y-intercept. Now that's assuming you got y by itself correctly. So y is already by itself though. So what's the slope? -1 divided by 3. What's the y-intercept? What is b? -3. So b is -3. That's your y-intercept. So if I want to graph that line, then how many solutions does that line have? An infinite number. That's why we're graphing it. So if I graph that line using the y-intercept, which is -3. So make sure you put it in the right place, -3 on the y-axis. And then from the y-intercept, I'm going to go down 1. Is that correct? Down 1, and which way? To the right 3? 1, 2. Oh, well, that kind of cheated here, because it's the same point from the other one. All right. So it has to be the same point from the other one, right here. So we already know the solution. What's the solution? Yeah, this right here, right? Is that your solution? So it's 3 -4, is that right? So that's your solution. What? The y-intercept. -3. Always do the y-intercept first, and then use the slope to find the other point. Okay, so that's where they intersect. So wherever the two graphs intersect is the solution to what idea? The system. So there's going to be a spot where it's going to say solution and a blank, and you're going to put what in that blank? The coordinates. What are the coordinates? 3, -4. Now remember, the solution is a point. So some of you, and we talked about this last class period when we did the circles and all, when you have to find the center, it's a point. You need to put that in parentheses. Whenever you talk about a point, it has to be in parentheses representing a point. So don't do this because you're not going to get full credit. What am I missing? What am I missing? Parentheses. All right, so that's your solution. So what I found is that my x coordinate is 3 and my y coordinate is -4. That's what I found. And you can check it, although you're not going to have time to check it on a test. But you can check it if you want to check it. You always go back to the original. So remember, what I found is that this point is a solution to this and this. So when I substitute in for x and y, the left side should equal the right side, left side should equal the right side. So let's see if that's true. So let's check the first one. All right, so in place of y, what will I substitute? In place of x, what will you substitute? 3. So the question becomes this. Is -4 equal to -5/3 times x? What's x? 3 plus 1. Well, what's a -4/3 times 3? I'm sorry, -5/3. What's a -5/3 times 3? -5. What's -5 plus 1? Which is what this is. So that point is on that line, but it needs to also be on the other line, right? So we got to check the other one. So let's check the other one. Now, do you have to check? No. The only thing you got to check that you have to check at this point is when you solve a square root equation. When you raise both sides to even power, that you do have to check for extraneous roots. So if I check here, what is y again? And I want to see if that's going to equal -1/3 times x. What's x? -3. And what's -1/3 times 3? And what's -1 and a -3? -4. All right. So I did the work correct. This is the correct solution. Okay, so let's do one more. Let's do this one. Number 2. Let's suppose I had this. Y plus x equal 1, and then x equal 3. Y plus x equal 1, and then x equal 3. So I want to solve this system by graphing. That's the question. Solve by graphing the directions. Okay. Let's look at the first one. What might you want to do with the first one? So I get y by itself, put it in slope-intercept form. Okay. So I have this becomes y equals -x plus 1. Is that correct? Mm-hmm. So if I look at that one, I can graph that line by just using the slope and the intercept, or I can use a t-table. It really doesn't matter. It's whatever you want to use. So what is, if you use the slope, what's the slope here? -1 is the slope. The coefficient of x. What's the coefficient of x? -1. So the slope is -1. Which I can write as a fraction. What fraction? Rise over run. -1 divided by 1. So my rise is -1. My run is what? 1. What is the y-intercept? 1. The y-intercept is 1. Someone else, though, could have used a t-table. Does not matter. Whether you use, for some students, when they see that -x, they don't recognize, even in college algebra, they don't recognize that the slope is -1. You see, they can recognize that the slope here is -5/3 because they see a number. They don't see anything here, which it's understood to be a -1. But you could have used a t-table. if x is 0, I get y equals the opposite of 0 plus 1. So where we saw the variable x, you plugged in 0. Remember using a t table. What's the opposite of 0? And what's 0 plus 1? 1. So when x is 0, what's my y value? 1. All right, I need one more point. So let's say x is 5. Okay? X is 5. If x is 5, I get y equals the opposite of x. And again, what's x? 5 plus 1. What's negative 5 plus 1? Negative 4. So I'll plot those 2 points and draw my line. Someone else could have used, let's say, x to be negative 3. Let's do negative 3, just to remind you what you would need to do. I would have y equals the opposite of x. That's how you read this, negative x, opposite of x. The opposite of x. What's x in this case? What's x in this case? Negative 3. Whatever that is, I'm adding 1. But what's the opposite of a negative 3? And what's positive 3 plus 1? 4. All right, so if I did this correctly, all those 3 points in that t-table should lie in the same line. So it does not matter whether you use, to graph the line, whether you use the slope and intercept or whether you use the t-table. It does not matter. You'll get the same line. So if I go and use the slope first and then the t-table second, let's see what we get. All right, number 2. So this is number 1. All right, so if you can use slope and intercept, you gotta plot the intercept first. What's the y-intercept? 1. So that's here. From that y-intercept, you use rise over run. What's my rise? Negative 1. So I'm gonna go down 1, and what's my run? Positive 1. Okay, so down 1, positive 1, right here. And then you draw your line. And you get this. Okay? If I'd done the t-table, if I used the t-table, one of my points was 0, 1, which happens, and 0, whenever you let x be 0, what is it you're finding? What intercept are you finding when you let x be 0? The y-intercept is what you're finding when you let x be 0. So I already found the y-intercept. That's this first point right here. That's the y-intercept. Now let's do the other one, 5, negative 4. So 5, negative 4, look. 5, negative 4. Oops, wrong one. 5, negative 4, right? So 5, negative 4. So what happened here? Yeah, so let's see. Did I write this right? Y equals negative x plus 1. Negative 1, 1. Slope intercept is 1. Okay, that's right. And then when x is 5, negative 5 plus 1 is negative 4. That's right. I'll say it again. No, 5, negative 4 is here. So I'm thinking that when I... Yeah, oh, yeah, see, it looks better if I do it this way. So you got to be careful. You see right here how I put my dot too thick? And so when I drew my line, did it actually go through that point right here? No, it did not. So yeah, you got to be careful. I should have put this in a pencil, but anyway, I get this. I'm sorry. That's why you don't do math in pencil. That's right. So, and I'm glad I kind of did this because some of you do draw your points real thick when you graph it. You gotta be careful. If you do it too thick, you could do what I just did, where I can't see very well where I need to draw the line through that thick point. Okay? All right, so just be careful. All right, and then the other one, let's do the other line now. Okay, so x equals 3. Now you may remember this, I don't think you do. you remember that x equals 3, there's no y, right? So that says that x is always equal to what value? 3. That's what that says. Now, you cannot use slope and intercept here. In all the others, we were able to use slope intercept form. Why can't we use slope intercept form when we have x equals 3? That's something you did in Math 98. Because we didn't get y by itself. There is no y. Slope intercept form is when you get one variable by itself. Y. And in fact, when we graph this line, some of you already know this, when we graph this line, what kind of line is this?
Vertical.
It's a vertical line. And a vertical line has no slope. Vertical line has no slope. So that's why you can't graph this using slope intercept. So you have to do the t-table. So one of the worksheets, on that worksheet that I gave you last time, you have one that's like y equals 6 or something like that, whatever it was. Just go use the t-table. Now, this says x always equals what? 3. So in the x column, you're going to have what? 3. That's what you learned last semester or the semester before, whenever it was. No matter what y is. So there's still got to be a y value, but I can use any y value I want to because x always is going to equal 3. So if x is 3, give me a y value. 7. If x is 3, give me another y value. 2. All right, that's fine. Now, if this was y equals, let's say, 3. If this were y equals 3, what would be in the y column? 3. And then in the x, you take some numbers. Now, I want you to notice when I graph 2 of those points, I end up with what kind of line? A vertical line. So x equals 3. Let's see, that's 3, 7 is here. Right here. And then 3, 2 is right here. And then graph it. And they intersect here, right here. So what is that? I'm sorry. 3, -2? Okay. 3, -2. That's where they intersect. 3, -2 is where they intersect. Okay, now let's just check it. Let's talk about checking this one. Let's check this. So my solution is what point? 3, -2. Now when you do the one that's on the worksheet, you're going to have a horizontal line instead. Y equal 5 is what kind of line? Horizontal. All right, so my solution is 3, -2. So let's check it. We go back to the original. So let's check the first equation. Y plus x equal 1. And where we see the variable x, I substitute 3. Where we see the variable y, I substitute -2. So is 3 plus, I'm sorry, wrong one. Is -2 plus 3 equal to a 1? Yes. Okay, so I checked the first equation. Let's check the second equation, x equals 3. Where we see the variable x, I substitute 3. Where we see the variable y, I substitute -2. But when I substitute, notice I only have which variable to substitute? 3. So is 3 equal to a 3? Yes. Okay? So there's no y to substitute because that equation didn't have a y in it. All right, so 3 equals 3, so that's my solution. It's a solution to both of them, so that's the solution to the system. All right, so that should be enough to get you through that worksheet that I gave you last time.